Welcome back to another episode of Design Lab, episode number 2. Today, I'd like to play around with TECHNIC. I don't have the full TECHNIC parts in frame right now. I'm just having power functions right now because I want to get this rigged up. I think now is the time. There's always the architectural side of Lego in the traditional system, but TECHNIC is the engineering side, and it's kind of scared me. It's kind of been daunting. At the very least, familiarize myself with some of the basic components and basic systems, and maybe we can build a basic contraption out of things today, or not today, but in this video. That's a little much. Maybe that'll be in episode 3. We'll be building a TECHNIC contraption, but I did want to just start familiarizing myself with TECHNIC parts. Fair warning, this video will be a little bit different, hopefully for the better. If you see, just seeming off the cusp, this is what I was planning on this series being like, is, even though most of this channel is unscripted, it's still more of like unscripted presentation style. This is truly nitty-gritty designing stuff. Just off the cuff. And plus, since this may take a while, since we're going to be experimenting with a bunch of different things, there are going to be a lot of jump cuts, as I'm probably going to be taking a few days to record this. So yeah, let's see if we can get this rigged up. I've got a fresh set of batteries in this battery box, and I also put an axle and a bush in here to have some proper clicky switches, and these are actually fun, and I don't normally do this, but that's fun. So yeah, I hope you enjoy, and I hope you can learn just as much as I will today. Before we get started, I do want to make a quick side note that throughout this video I'm going to be personally referencing sariel.pl's gear tutorial article a lot. It's linked in the description. Gotta go check Sariel out. Sariel does just this really cool stuff on their blog. But Sariel did a article that was a tutorial about gears. Covered everything from, really basic stuff like driver and follower axles to gearing ratios, all of this complex stuff, including the math, including the more abstract math. Gotta go check out Sariel. I'm also going to be referencing things like pictures on Pinterest and pictures just straight up from Google to know of I can probably make my own designs, but I do want to know how to design some different components first. Sariel.pl gear tutorial linked in the description. Without further ado, let's get into it. Okay, so the first thing I want to do is I want to see if I can figure out how gearboxes work. So if I put this here, and if we take some, I believe these are 12 teeth single bevel gears. No, okay, goes in facing like this. Yeah, okay, slides in like that. Then another one right about here. I might have to rig in something just to keep this gear stable, but we'll hook this up to the medium motor, and then we'll secure. So yeah, so let's see. And then I've got my remote right here, and yes, I'm using a blue base plate. It was the first one I could get my hands on that was free. Wait. Oh, I'm flicking the wrong lever, so. And yeah, so I'm gonna need to secure something. So let me rig this up, get a quick plate. I'm also, I'm using this notebook that has been empty for forever that you saw in the intro. Actually going to be using this throughout the series of Design Lab. Going to make a quick sketch of a gearbox, and then we can use that for whatever. But like I said, I'm going to get this rigged up, and I'll see you in just a second. Okay, so as you can see, I have done a horrible toilet drawing of a gearbox. Hopefully that'll be another thing that outside of my Lego skills in this series, my sketching skills will also improve throughout the course of Design Lab. But as you can see, and I don't think I fully made myself clear in the last clip, what I'm aiming to do is I want to figure out, you can have a max of probably 3 gears in a gearbox. 4, and I don't think it would move. We'll probably test that too, just to make sure. But I want to see which of the 3 can be an input and which of the three can be an output, so we know that when we're making rigs, what can move what and what can't. If we zoom back out, you can see I lifted the whole gearbox up by a plate because just sitting it down on the base plate itself made the motor not be level with it. So if we see, and again, reviewing the drawing, this is supposed to be where the motor is, and then these are the other two axles that I connected. We might just make a small rig with like a Technic brick or something, but if I do this, you can barely see it. So again, I will be making like just a small rig with a Technic brick hooked up to it to make it come across clearer on camera, but it's moving. So what I want to do is I'll grab this and I'm just going to write really quick. Okay, so that is functioning as an input, and then again, I'm gonna rig up some Technic bricks, or maybe I'll put these on the axle end of these on there just to demonstrate. But that's interesting to see. So and then I will grab another bevel gear just to make sure that I was correct and that you can't have a full 4 gears on here. But yeah, let me do that real quick. Alright, if this pops off, I guess I'll just have to take my word for it, or pay closer attention to the axles, or we can do a slow-mo, whatever. But let's try it again. Yep, you can kind of see it. It's not moving the bricks too much, but I'm looking through the camera right now, and I mean, it's running smoothly. So we can safely say that the front and back would function as an input. So now, if we take this off there, then let's actually hook this axle up. Oh, well, that answers that question. Right, so I guess if I had just paid attention to the mold, we wouldn't even have to have conducted that test. But if you look right here, you can see there's no axle hole, right? This is just solid plastic. So if we turn it around, you can see that there's a clear axle hole there. So I'm just gonna make a note of that. And as you can see, or hopefully if it'll focus, we can tell which is which. So last thing I want to do is I brought another gear over. It's the exact same type, and I don't believe that these are the only gears that can function in this gearbox. But I just wanted to test consistently with those. Again, I'm sure if we really pay attention, if we really do some good math, which we did enough of that in episode 1, we're not doing that much math this episode. I might do some off camera, but I'm not going to bore you guys with it. If we rig all 4 sides up, what I'm assuming we'll see is that the equivalent would be 0, like that the output would be 0 of the main follower axle, and so we wouldn't be able to have 3 outputs. So let me just rig that up real quick, because if you think about it, all of these are trying to mesh together and work simultaneously, and you can kind of see it in frame because I keep peeking over at the camera. So I might rig this up off camera, but if all 3 of these are trying to turn all 4 of these, excuse me, are trying to turn the other 3 simultaneously, then what I have a feeling we're going to see is that none of them will turn. The result from one input will be 0 outputs, whereas with 3 gears, the result from one input would be 2 outputs. Does that make sense? I think it makes sense. The 4th axle I added in, it kept wanting to fall out. So obviously I needed something to secure it, and so I just rigged up this 1x4 Technic brick with 3 modules in the side to a few parts ahead lying around to make the heights line up, and no way. I was wrong. I was dead wrong, guys. Okay, so I'm gonna do like I did a second ago. I'm gonna rig all of these up I don't know, to something to make the motion a little bit clearer. But there are 3 outputs there. You guys can see, if I touch that, it slides my finger off. Just like if I touch these 2, it slides my finger off. I was totally wrong. I'm gonna admit it. I did not think this would work. I could have sworn that 4 gears, that 3 outputs would not be possible. And granted, the set this came from, there might have been a 3rd output now that I think about it, but I don't remember for sure. But that is astounding me. See, that's why we do these tests. That's why I've started Design Lab. So to fool around with some parts and maybe we can all learn something. Let me just do one last rig to really demonstrate the fact that this is working. And I can't believe it. And if I take this off, I want to make sure the gears are actually meshed together. Just, yeah. Guys, it's working. It's working. Okay, be right back. Okay, so I actually swapped out all of the TECHNIC for a universal joint on each output. That way, you know, once the motor starts running, you can really see it flopping around. I think that would be a nice visual demonstration without having to redesign this really janky rig too much more. So let's try it. Yep, y'all can see it. Oh, and one of them fell off. Oh my gosh, I'm telling you, I'm still stunned a bit. I really didn't think that adding in 4th gear would work. I really didn't think 3 outputs were possible. And again, it's been a while since I took that set apart, much less put it together. And so there very well might have been 3 outputs, but I do not remember that. I thought that would make all 4 of those gears stand at a standstill. It would sound the motor would sound like it was snagging, and there would be 0 outputs. But obviously, that is not the case. Oh, that's why it's not running, because the driver gear came out. That's so interesting. That's so interesting to me. I mean, that's just fascinating. That truly is. Okay, so that is fascinating. That is fascinating. Okay, so I'm sure there are probably some other, you know, things we could solve with gearboxes, but I think that's enough for today. I think I want to move on to the next item on my list. A quick side note is all 4 of those gears were 12 teeth single bevel, meaning that all 3 of the outputs were the same, right? The gear ratio would be 1-to-1. For 1 turn of this gear, all 3 of those turn once. So that could be really useful. I don't know what, because like I said, I'm just been recently trying to learn Technic. But surely a tri-output 1-to-1 gear ratio with seriously no idler gears, meaning no gears in between the input and the output, unless I'm doing the math wrong and like gearboxes change the ratio some, that is really interesting. That could be very useful, I feel. Okay, let's move on. Okay, I know I said this was going to be the last of the gearbox segment, but I was wondering, you know, in the last clip, you probably heard me say that the last setup was a 1-to-1 ratio. So I was wondering, well, would you be able to mesh other sizes of gears together? What could you do? So I tried, and I believe this is like a 24 teeth single bevel gear. Yeah, looks about twice the size. But it doesn't seem possible. I tried, you know, meshing it together, but it's too long. As you can see, probably see, it won't even go in, right? So it doesn't line up with the axle hole, so obviously it can't go in. Double bevels would be too thick, and I think certain other types of gears wouldn't really work either. So it looks like 12 teeth single bevels are the way to go. And then I hadn't thought that, you know, you could probably even rig up a gear chain. So if you needed to gear up or gear down, which gearing up would probably be the more likely scenario, because I mean, gearing down from 12 teeth would be like a minimum of like just 8 teeth or something. So it would be useful, this would definitely be a very useful rig, I can tell. But you would, if you needed anything else, you can't do it straight from the gearbox. You need to take the one of the outputs, get that back in frame, one of the outputs, and take that out and gear it up or down depending on your needs. But I feel like this is a very helpful start, and so I feel like that could help us along the road. I have decided, you know, I'm not going to attempt to make a mechanism of any caliber in this video. I feel like that would be a bit much. So instead we're just going to test, you know, some of the basics, try and figure some stuff out, and then we maybe in another episode we can try and figure out how to make a contraption, because I do have some idea of what I want to do. Alright, let's get on to the next thing. Okay, so the next thing I want to play around with is setting up a gear chain. Now I know this is pretty basic, and I have a concept you'll be able to see in the notepad of how this would work, but I just want to test it to make sure I am correct, and if not, figure out what I need to change. So the design I have here is just to start out, just a 5 module long TECHNIC beam, a line of gears on each module, all 5 gears being 8T. It might not even be a bevel gear at all, but like all of these will be lined up, and then I'll have an axle coming out of the ends, and then in between those I have these axle pins, which if you're real smart, you'll have noted that since these are the tan versions, there is no friction, meaning that the gears should, and I'm emphasis on the word should, spin freely. So let me just rig this up real quick. Now let's rig the motor up, because I have it turned on. Yeah, I'm definitely gonna need a bush in a second, but yeah, so let's, okay, yeah. Okay, I'm gonna cut, and in that time, I'm going to grab a couple of bushes, and I'm going to check to see if those are double bevel gears or not. Alright, so as it turned out, these are not bevel gears at all. These aren't double or single, these are just plain and simple gears. So, okay, so what if I grab a half bush? Okay, so I've added a couple of spacers on. You can see I've got half bushes here and here, on the underside to where it's closest to the motor, and then on the other axle I did the exact same thing, and then I don't even know, will I need that full bush? Yes. Okay, that could probably be made more efficient in just a second if I replace this with a half bush, just saying, but just to make sure it is working. Okay, so yeah, so this is a successful design. Problem is, this is still a little loosey-goosey. So I'm gonna get another set of half, see, this is wiggling around, so I'm gonna get another set of half bushes and put one here and here and take this full bush off. Hopefully that should make it even more efficient. Okay, so let's make sure this is still working okay. I'm gonna hold this still just to make sure. Okay, so it's clearly working. If I ever make an actual system or contraption out of this, obviously I'd need to secure this a bit better so that all this does is just transfer the motion from one end of the gear chain to the other and not actually make the entire gear chain spin around, because that's a bit dumb. So I might actually, you know, bring the base plate back over, hook it up to a TECHNIC gear, and at least have it secured. But let me just, if I just hold it like this, yeah, there's definitely a good output. So I want to master this, but I do want to get some sense of actually making this structurally sound, and to the point where we can actually take some sort of dumb feedback off of this. So get in a second. Sorry for all the jump cuts in the video, by the way. Alright, take your guess. Will this work, or will I need to modify it? Haha, it does work. Do need to lift it up some, as it is scraping the base plate. So I'll do that real quick, and maybe we can just, you know, to say we've done it, we can just take some sort of output from there, even if it's just flying something around. In the process of sitting down, I just about had the tripod fall on my head. So that was almost unpleasant. But anyway, I just put a round 1x1 plate, or just a stud piece, on either end of the TECHNIC brick, just to raise it up enough. Okay, so it's a little janky. I mean, as you can probably tell, let me zoom in a bit, so you can probably tell if I do that. It's more grinding across, if you look right here, it's more grinding across the sides of the part. So I could probably take the half bush off, run the axle into the TECHNIC brick, put it back, and then both sides would be stabilized. So yeah, so this is turning out to be a bit more complex than I thought, but I'll be right back. Okay, so things aren't quite lining up like they were a second ago. Yeah, if I put this, sorry I'm not finishing sentences, I'm more just thinking aloud right now. Then that's too high. Okay, so right now what I want to do is let's just take the motor off of the base plate. So what I did is I took the half bushes off of, they were both in between the beam and the TECHNIC brick. So what I did was I took them off of their current position and stuck them on the outside of the TECHNIC brick just to fully secure everything. So if we run this, okay, yeah, that, so we might need to secure, and then things aren't quite level, but it is working. So do that, take this, and then do a little something like that, which just might be too close, so I might have to elevate it a bit more. But if I do something like that, then where's the remote? Okay, so that wasn't nearly as interesting as I thought it might be, but the proof of concept is there, right? There is a clear output from the motor into the driving gear, which, by the way, these other 3 gears, since they are all 8 teeth, it's, again, a 1-to-1 ratio. And I might, since this is a bit easier than the gearbox, I might see if I can rig up a gear for different sizes. This is the smallest gear you can get, so we couldn't gear down, and I hope I'm getting my terminology correct. We couldn't gear down. We could gear up to maybe get some more torque. I'm just gonna secure the IR receiver here to make the signal a bit more consistent, but I think that should be, last thing we do is to just try and gear up a bit, which means we might have to raise up these a bit more, which, I mean, that's not going to be a problem at all. So if I remember correctly, and I will go reread that section of the sariel.pl tutorial after this, it's for these middle 3 gears to be idler gears, meaning just transferring motion and not actually affecting the result by gearing up or gearing down. They all have to be the same. So we'll leave those 8 gears as 8 teeth. Ooh, so we're going to need to take this one off because of the added space. Now let me slide this gear on, and this will slow the rate down a bit. I don't know what, I've not calculated it, not calculated this gear ratio, so I don't know the exact amount, but this should slow it down, while at the same time it would also mean that we can get a bit more strength out of this. There we go. I think that's not secure. Meant to do that, definitely. Okay, so with the current setup, the motor is raised up off of the base plate by 1 plate, and the TECHNIC brick is raised off by 3 plates, or 1 brick, and that's actually what I did, is for one of the sides, I just swapped it out. So if we do this, yeah, it is working. Okay, nothing's scraping. Sounds pretty smooth. I'd have to watch the footage back to see about the speeds and to see how much it's been slowed down, but if I'll calculate the gear ratios real quick, and maybe at this rate I'm not going to take an actual output from this, but this is good. Okay, so gear chains are pretty simple, and assuming I, adjust the heights of everything correctly, adjust the widths, adjust everything, I could probably, I could gear up even more from this. I might need a bigger gear than 8 teeth, but this is working. All right, so the math is done, and here's how gear ratios work. Again, referencing sariel.pl, gear tutorial, link in the description. So the ratio is the follower gear's teeth to the driver gear's teeth. So in this case, the driving gear had 8 teeth. I checked that the follower gear was 24 teeth. So then you would divide the follower gear's teeth by the driving gear's teeth, and you get the output. So this is a 3-to-1 ratio, meaning that it takes 3 turns of the driving gear to equal to 1 of the follower gear. So that means that we have slowed, and this is funny because I didn't even do this intentionally, but I actually did the example that is in the tutorial. So this is actually slowed down 3 times. So if we do this again, that is 3 times slower than when we had this gear as the follower gear. So that's really interesting to me. Yeah, I'm assuming, I'm sure there's probably a more efficient way to do this, and if we had a longer setup, we could probably, just mesh together more gears. I'm sure, like, maybe we got a beam like this, like one of these L-shaped beams. Maybe we could gear it at an angle. Actually, you know what? I want to test this. I'm gonna save that setup, but I'm gonna grab 2 more gears and 2 more axles, and I promise we'll move on after that. But I just want to see if you can gear at a diagonal. All right, so I'm not actually gonna make a structure and actually, fully run it with the motor, because unlike this one where I was actually trying to make sure it would run and get it to run properly, this one's just going to be a proof of concept. So here you can see, on one side you can clearly see the L-shaped beam. I've got the same 2 gears like this. You could put the motor here and have it be the input, or you could put the motor here and have it be the input. If you put the motor here, then you'd be gearing up and it would be the same gear ratio. If you put the motor here, then you would be gearing down and it would actually be sped up 3 times. So I'd have to do the math again. But you can clearly see what this is. So I actually have the 8 teeth gear at the vertex of the beam, and then I just have 24 teeth gear 2 modules over, so to just give it enough space. So it's pretty much the same concept as that, but yeah, I can definitely tell this would make for a much more space efficient design if you're needing like a large gear system. Yeah, I think these are the basics we're going to stick with. I might make a quick sketch of these in my notepad, or at the very least, do the math and just like put all the numbers down of like, okay, brick raised off, TECHNIC brick raised up by a brick, the motors raised off the base plate by a plate, and then just all that to remind myself of the positioning, or I can just rewatch this video, who knows. So yeah, I think that's another thing. We're actually, as far as ideas I had for this video, we're actually about 50% of the way done now, so halfway mark, woo! Okay, so the next thing I wanted to try and figure out today was how to make linear motion. So I can grab this axle and stick it in the motor. Turn the battery back on because I forgot to do that. You can see it's a very spinny thing. It doesn't function like a piston or anything that pushes. And honestly, I feel like pushing things would be very beneficial and something that I would need to figure out. So I was trying to think, before I even started recording this video, what would be the best way to get it to transfer this circular motion into linear motion. So I realized rack and pinion setup, duh. So that's what I want to figure out next. Or else I only have one of those in my organizer, which that might be enough, but just in case, might take a picture of this and borrow some of these rack and pinions, because I think, yeah, there's actually 4 elements right here, and I'll just watch this footage back so I can know where to put them. So if you give me a second, on Pinterest, I did save a simple rack and pinion setup, which looked very interesting to me. So if it'll come across not very well, but you'll see what I mean. So yeah, I can't enlarge it, but there's a beam right here running across. You've got a plate on top of it. Then on top of that plate is racks, or the pinions. I get the two mixed up. And then on either end, okay, so the last stud on either end, there's just a simple round 1x1 brick just to keep it from flying off. Then from what I can tell, if you look here, so you've got something like this on either side with an axle running through this top half thickness module and a gear in between each of the two of them. It looks like 8-teeth gear would work just fine. And then here and here you've got a linked 2, it appears, axle just running through that. So the interesting thing to me was, in this case, it doesn't look like the gear would be running, the rack would. And let's see if we can figure out how to make this work, because I definitely want to try and figure this out. This may be the most complex thing we've done so far. So, fingers crossed, applesauce. Jump cut will come true. By the way, that was such a weird segue. Why on Earth, or any other planet for that matter, why did I say that? By the way, the link to this YouTube video will also be in the description. It is an actual YouTube video for how to set up a rack and pinion. I wanted to challenge myself, so we're not watching it. So I've got all the stuff I need here, plus I'm substituting those bricks for just 1x1 cone elements in gold, because I thought we should be fancy. Okie dokie, the parts have been gotten, and these have been taken off of the Talon Fighter, which you'll be seeing in another video fairly soon. I found a nice royal red plate. No, that's not an official Lego color, I just thought I might be fancy. But I found this off camera, so we're gonna use it nice and spicily. So now we need length 2 axles. You can use the red variant or the black variant, it appears, because there's no difference to my knowledge between the two other than color, unless one color might weigh more, because I think that's a thing, and if it isn't, then whoopsie. Okay. So that, I don't know if you can see it. Let me come back into camera. Yeah. So it's exactly the other half. Interesting. Oh, duh, because that's basic math, right? Because this is 1, this is a whole length, this is a half length, and this is half length. 1/2 times 2 plus 1, that's 2. So, duh. Yeah, I've done enough math here lately. You can tell my brain is starting to fry. So we need to line the gear up and just quickly place it like that. In fact, I'm going to squeeze its little cheeks so we can slide the axle in like that. Okay, so we need to put in our rack setup for the gear. Mesh the gear into that, and that's going to hold it still while we slide the axle in, or at least it should. It should, as long as I don't mess stuff up. There we go. That's on. Make sure that's in frame. And, oh, okay. Yeah. Whoa, what just happened? Ooh, that just curled up on itself. Okay, so I might need to this up to a Technic gear or something. Why did that just curl up? Okay, gonna take care of that and we'll be right back. The other side of that pin into the very end module. Will this work? No, it shan't. Okay, so we might need something smaller. Where's that 1x1 brick? Yeah, this should work, right? I don't see why not. Which, hindsight to 2020. Yeah, so if we secure all of that to the base plate. Oh, it's offset. Yeah, I should have seen that coming. Okay, so we're gonna need 1x2, which I have a lot of Technic bricks on hand because I knew I'd need it for this video. So, yeah, I feel like and engineering Barefoot Contessa, which I don't even like Barefoot Contessa. Sorry for the Barefoot Contessa fans. Why am I so on that? Oh, this Beams being a finicky little boy. Girl. I can't tell which. You know, I shouldn't have said it should be this simple, because every time I say that, every time anyone says that, never is. As you can probably see, it is now officially secured. You can kind of see the layout there. I just put the middle one of one and then the left one of the other. So it's all secured. So now let's put it back together. Found a 2x8 brick first, which that's no problem. That just means we have 2 extra studs hanging out. Oh. Well, the good news is that works. The bad news is one of my slope cones just flung off into my little part sorting tray, meaning that a slope isn't strong enough, but we can reinforce that. The thing is, if I do... Oh, wrong way. Oh, it's come off. Okay, so yeah, see kids, or not kids, even though the FTC says you're all kids. Yes, I'm salty. We can take, we're gonna have to take the motor back off, so slide that out. How do we reinforce this? We need to reinforce it with something. Let's try, ta-da! Oh, yeah. Of course that would happen. It's like my hand goes in frame. Now we've got 2 studs on either side, so it's raised up a bit. And this should work, so let's place it back in. Everything's back in place. Let's see, does that make things more secure? Let me make sure everything's in frame, and could be reinforced more. But I think what would be an even better idea is only reinforce one side, and that way, this is the first step. I mean, I could essentially make a gigantic battering ram from this if I wanted to, or maybe not gigantic, but I have an idea. So let me grab this 24 teeth gear. I don't know the gear ratio for this because of the fact that, you know, there's no ratio involved. Oh, I see. Okay. This won't fit, but I do want to see if I have an extra bit of strength in there. Update, I realized, you know, what's the most basic thing that is famous for its extreme amount of torque, but low amount of speed, that would work really well for rack and pinion if I redesigned it just a smidgy dash. The worm gear. Okay, so you can tell, I mean, that should work, right? The only problem is this would need to be wider, I think, or at least I think that's... No, because that's like, no. Okay, so it would need to be still like this, I think. Gonna do a little bit of experimentation. Yeah, I think this will work. I think I'm gonna need another reference picture. Just saying. Just so I can get some idea. And then once I start learning the components, right, and start learning the basic concepts, then I can make whatever design I want. Okay, so in the process of that, I think I want to substitute the last thing on my list that I wanted to try and do for something else. I don't want to design my own casing. I don't want to do anything fancy. I just want to design a very basic worm gear system because I forgot how complex these things are. So I think the first thing to do is figure out the measurements. I figured, you know, since one bush, one module wide, right? I believe it's about 1.5. I think we need to test that. So on 2 axles, what we're going to do, same length 5, we're going to take a bush and a half bush and put it on there. And then we're going to take on another axle and put a worm gear on there and just compare measurements to make sure things are all correct. Thinking maybe 2 plus the half bush on either end would be 3. So let's compare. That's too much. So I think we're going to safely say it's 2. All right, so I feel vaguely comfortable saying that it's 2 long plus the 2 half bushes, which would be the minimum width, because if I take the worm gear and toss it on an axle, you know, most gears stay in place. This one requires a casing, so it doesn't do that. So let me modify our original rig and get my worm gear from behind the desk. So you guys know that tutorial I said I would be referencing, and I've said I would be referencing several times throughout the video. I forgot to reference it for this. Yeah, okay, and look, worm gear on rack extension. Man, that is really simple. Are you kidding me? See, kids, this is why we use the internet. Okay, so let me try and build that real quick, because I have a feeling I can be done with that in like 5 seconds once I have the parts together. I think I've got everything. And I'm totally gonna need to clean my desk up after this, because this is horrendous. Okay. I'm starting to sound like a New Yorker, even though I'm from the South. The 2 rows of rack can be used. The worm gear must be placed between lift arms, not between bricks, to obtain proper spacing from the rack. Okie dokie. That seems manageable. See, it's still sliding a bit. Is that supposed to happen? On this episode of Did Ashford Build It Correctly, we're going to be flicking this lever. No way. Okay, it's getting a little bit snagged. I bet I can fix it. Put our plate back on here, because I think that might have been part of the issue. Okay, let's try it again. No way. No way. And it's like it's running. It just runs. Like, just like the motor runs. I mean, this isn't even like technical running. This is just like skipping like a little fawn. That was a really weird statement, particularly in a mechanical engineering video. Okay, so I'm assuming... Okay, so those don't need to be rigged together, because that would probably inhibit the motion, in theory. And then I'm assuming you could put a stopper on the other end of that TECHNIC brick, else you could just hook it up to a battery mount. So this is supposed to be even more secure. And it's definitely getting caught in places. But it's working. And it's doing a real good job. Right, so I'm gonna make a note of this, and as you can see, just from one episode of Design Lab, I'm gonna be having a little over a page, which, as you flip through this, you can see that younger self decided that this notebook needed clear page markers. So thank you, younger Ashford. Yeah, like I said, I'm going to do a quick sketch of this, and yes, it's going to be a toilet sketch, just like every other sketch in here. In case you're wondering what I substituted to use the worm gear, I had originally wanted to just get a basic understanding of engineering math, but that's going to become a bit more natural as I'm doing things, and so I need to learn physical concepts of what I'm trying to do before I'm just, trying to make up math problems for myself, which I don't even know how I would do that. So yeah, I thought this would be a much more interesting take. Besides, I completely forgot worm gears existed. And with that beautiful thing, I think that wraps up episode 2 of Design Lab here on ASHTAGbricks. If you enjoyed this video and stuck with me through all of the jump cuts and through all of the pauses and everything, and you enjoyed the video, please make sure and drop a like on it. If you learned something, please make sure and drop a like on it and subscribe, because this is only the 2nd episode. I've got just so much more to come. Got so much more I want to investigate. Plus other shows like technique showcases. I do let's builds, time lapses, all sorts of stuff related to design and engineering regarding Lego, and including the occasional rant about Lego Masters. So yeah, thank you so much. Again, huge thank you to sariel.pl for making that tutorial back in, 2009, and whomever made the YouTube video about that original rack and pinion design. Again, all of these links will be in the description for all the things that I've said, and I'll make sure and keep track. First 2 pages of this notebook have been, or not the first 2 pages, but first page and then some have been filled up during this video, so we're going to put that back here. But I feel like I've learned a good bit. I know that the way I thought about making a basic gear chain works. I have plenty of notes about how to properly use a gearbox. And yeah, things like linear movement and worm gears are mildly less terrifying now. Yeah, I feel like we're on track to make a contraption in the future. I don't think we're quite there. I don't think I'm quite there. But I think I may experiment with some stuff off camera. Get all of the parts that I've used. I'll get all of that put up. Put stuff back on Royal Talon Fighter. And yeah, thank you so much for watching. And I will see you in the next video.